So I'm also going to talk about an alternate method of applying transformations to the graph of a function. We used this method when we were working with exponentials and logarithms. And it's often useful if you have a bunch of complicated transformations and you find that you're losing track of which point is which. It's especially handy if you have a whole lot of key points to keep track of. So in this method, we're going to look at the input and output of the original function. And then we're going to go backward and forward to find our values of x and y. In this example, our function f has a key point at -4, 2. So when its input is -4, its output is 2. It has a key point at -1, 6. So when its input is -1, its output is 6. We have a key point at 3, 4. So when the input is 3, the output is 4. And then we have a key point at 4, -2. When the input is 4, the output is -2. Now, in the function we're actually interested in, the input of f is the expression -1/3 x plus 2. We want to find the value of x that goes with that. We could do this by solving for x 4 different times, or we could introduce a symbol for the input and solve for that symbol once and for all. So subtract 2 from both sides, multiply both sides by -3, and we see that to get our x value, we take the input of f, multiply it by -3, and add 6. -4 times -3 is +12, plus 6 is 18. -1 times -3 is +3, plus 6 is 9. 3 times -3 is -9, plus 6 is -3. And 4 times -3 is -12, plus 6 is -6. Now, going from the input to the output, that's applying f. And then to get from the output to y, well, y is 1/2 times the output minus 3. So we take the output values, multiply them by 1/2, and subtract 3. Multiplying by 1/2, remember, is just dividing by 2. So 2 divided by 2 is 1, minus 3 is -2. 6 divided by 2 is 3, minus 3 is 0. 4 divided by 2 is 2, minus 3 is -1. -2 divided by 2 is -1, minus 3 is -4. So that's how we get our x value and our y value for our actual graph. The graph has a point at x is 18, y is -2. It has a point at x is 9, y is 0. It has a point at x is -3, y is -1. And it has a point at x is -6, y is -4. Connecting those dots, we see So we got our original graph, moved down, squished vertically, stretched out horizontally, and it also appears to have been flipped horizontally. And that's what we would expect by analyzing these transformations. 2 will move us to the left. The negative 1/3 will flip and stretch horizontally. The 1/2 will squish vertically. And the negative 3 will move us down. So that's pretty much what we would expect to see. The one thing that might confuse us is it looks like we moved to the right, but remember we moved to the left and then we flipped. So that would make us end up to the right of where we were if we moved to the left and then we flip horizontally. So which method should you use to apply transformations? Whichever you find easier. Whichever you find easier to keep track of. Both methods work perfectly well. You should choose whichever one you prefer.